So now we move to our last speaker, and we were planning to have two, but we have only one of them. We have Sebastian Pena Serna, and welcome. He will give us good insights of a very interesting project, DIGITbrain, and the title of his presentation is Data Models and Algorithms as Reusable Models for Digital Twins. The floor is yours, and thank you very much for joining us.
Okay, thanks a lot. So good morning, everybody. I'm happy to be here. Unfortunately, my colleague, Andrew Storr, couldn't join us today. He has some personal issues, so he's in Germany. But it doesn't matter. We are going to do our best and present and deliver the message about DIGITbrain and we want to achieve with that. So our approach is, well, digital twins. We have been using, or many manufacturing, especially in the manufacturing industry, have been using digital twins for, let's say, a couple of years already. Data plays a very important role in digital twins. However, using and reusing and trying to adapt or extend digital twins is still very complex, and not everybody managed to do that, and normally they need to try over again. So DIGITbrain was trying to actually solve these kind of challenges. So it was interesting to see that the previous talk was actually talking about data and where is data and what are the challenges behind actually accessing and using and extracting the value of data. And very important from the point of view of the manufacturing companies and especially from the SMEs. So we can claim, and I think that we were hearing that before, every manufacturing company has data. There is no doubt about that. The question is, can they really start extracting value from that data? And if we want to answer that question, then we need to know what is the infrastructure that they have. They have the IT infrastructure that they need, the OT infrastructure that they need. Do they have enough sensors? Do they need additional sensors? Do they need to normalize the data or do something with the data before they can actually start using it? And of course, there are companies, experts, like the one before, ITI, who are helping manufacturing SMEs dealing with that. The question is, when these solutions are there, can they solve all the problems that they have with these solutions, or is it just one solution that they are seeing, and when the next challenge comes, then they will need to see how to adapt or how to find a new solution to deal with that. Now, since the manufacturing SMEs especially are dealing with this kind of problem, we wanted to start giving an example about how an SME can actually start using and leveraging the data that they have to actually get some value. So in this hypothetical example, we were considering an SME with an AN machine, and what they want to do is to optimize the printing surface quality of the products that they are printing. For that, of course, they need to consider the complexity of the part, the characteristic of the powder, the capacity of the laser, and sensor, real-time sensor data coming from the machine is also important. So if they want to get that kind of information and be able to analyze and extract that value from the data that they are receiving, normally what they are going to do, or the solution that some experts are going to propose to them is, okay, they need a digital twin. And a perfect digital twin will be developed for them. That digital twin will actually have the right machine learning algorithms, will be able to collect the data that they need, will be able to access the sensor that they are looking for, and at the end of the day, deliver the answer that they are looking for. So it's perfect, work for them. But the question is, what happens if actually now we are going to deal with a different product? Or what happens if I want to do the same thing, but I'm not going to use this AN machine, I'm going to use a different one. So there are a couple of things where reusability for this kind of black box solutions, digital twin solutions, is a little bit complex. And there is where DIGITbrain has been working on for the last 3.5 years on trying to solve this challenge, trying to understand how can we make digital twins in such a way that they are reusable, that people can start adopting them, and that they can change it, they can explore, they can learn from the process, and actually reuse it whenever they need it, or exchange the components that they need to exchange so that they can achieve the value that they require. So the first step in this is we need to get rid of this black box digital twin. And the way of doing that, or the way that we are doing that in DIGITbrain, is by modularizing that. We have 3 main modules, and these 3 main modules are data. Data is very important. Then we have the model and the algorithm. If we look a little bit behind the scenes, we have actually the possibility to have more than one data. So it's not just a one data, it's about all the data that is required as input or as output for my digital twin. I have a model that is actually representing the aspect that I want to analyze, that I want to optimize from a manufacturing process. And finally, I have the algorithm, which is, at the end of the day, a collection of microservices describing or providing the functionalities that is required to either analyze the data, to collect the data, to process the data, or actually to do the analysis, to do the optimizations, provide the results, perhaps to provide some visualization. So that modularization is what, at the end of the day, help us to be more flexible, to be able to replace different of those modules, to replace what of the data, to replace, for instance, the model, the examples I was referring to before. We have an AM machine for a specific product. Now, we want to print a different product, but we want to use exactly the same kind of digital twin. So we just, in this case, we only need to replace the model, a model that will conform with the description, with the characteristic of the part that is going to be printed. Or what happens if at the end of the day, I want to include an additional, let's say, analysis into the data or into the digital twin that I'm having, or an additional visualization. I just need to include an additional microservice. I don't need to create a complete new digital twin. I just exchange or reuse the components that I need in such a way that I get the solution I'm looking for. So how does it work? In a very high level. For details, I will give you some pointers at the end of the presentation. So we talk about data, model, and algorithms. Let's simplify that by saying it's a module. So we divide that module into the asset and the metadata. The asset is the actual thing that, let's say, the owner of that module has the value that they want to protect. So for instance, if we are talking about the microservice, we are referring to the Docker image. If we are talking about the model, we might be referring to a model file. And if we are talking about data, we will be referring about a data resource, a database, a data lake, these kind of things. So those are the things that they want to protect. We don't want, we as the DIGITbrain solution, the platform that we develop, we don't want to have that information. We don't want to give them the opportunity or the possibility to upload that somewhere where we can keep it. We don't want to have that. That says their IP, they want to protect it and they have to protect it, and we want to help them to protect it. So the only thing that we need is actually the description of that specific data, of that specific asset, what we call the metadata. So the asset is owned, let's say, by the developer, the IP owner, and they manage through a repository who has access to that repository, how they want to provide, let's say, access, and if they want to keep that access alive or not. So they have completely control over that asset, and the only thing that they want to, or that they need to do if they want to use the DIGITbrain solution, is to actually publish the metadata. Why is that important? Because after every single module has its metadata, what we can do is we combine the metadata from the triple that has been identified. As I was saying before, you remember about these different modules that could be exchanged. So now we have identified the right data, model, an algorithm that we want to bring together from a specific solution. Now, each of them has the corresponding metadata, and since we have identified that application, that solution, now we combine the metadata of the individual modules, we compile and create an executable out of these metadata, and finally, we deploy that executable dynamically in the edge or in any cloud that is available through the DIGITbrain solution. So at the end of the day, it is not up to us to define where do you want to deploy it. It is up to you as the user, as the one who wants to benefit from the digital twin solution, when do you want to have it? Do you want to have it from a, let's say, cloud provider which is located here in Spain, or one that is located in Germany? Or do you want to use one of the edge devices that you have in your shop floor to do the deployment? Or actually, do you want to do a hybrid one, deploying part of the solution on the edge and the other one on the cloud? So that's the very high-level description of what DIGITbrain is about, what DIGITbrain solved from our perspective, and the contribution of DIGITbrain toward democratizing the adoption of digital twins, especially in the manufacturing SMEs, or for the manufacturing SMEs. Part of what we have done also in the project is we did the validation. So we have 21 industrial experiments that we collect over the 3.5 years. Every single of those experiments, it was at least a team of 3 working together in developing that. It was the manufacturing end user, an IT expert, or an expert helping them in the development of the digital twin, and of course, a digital innovation hub supporting them in going through the process, and behind the scenes, all the technical team from DIGITbrain was supporting them. In addition to that, we also have 10 technical examples that we were using to validate the whole solution. Just to give you a couple of details or a couple of examples of the type of digital twin solutions that have been developed. So we have production optimization using machine learning. We have discrete event simulation for metal products. We have a couple of, actually 4 if I remember correctly, 4 different industrial experiments working with optimization of different aspects of additive manufacturing processes. Of course, there were some examples about predictive maintenance and even life cycle assessment. So we have a broad range of real use cases that help us to validate and to make sure that we have developed have a practical use in the industry, and especially for the manufacturing SMEs, which, as we know very well, they have limited resources, not only economical resources, but also the resources from the point of view of the expertise that is required for using and deploying this kind of solutions. And the final slide, and the final point that I want to make in this presentation is about the commercialization. In this project, it was not only about developing a nice solution, developing a theoretical solution. As you have seen, it was about developing the solution, validating with the industry, and actually going forward and making a commercial offer out of that. And we have done it, and this is now available on the Mgora workspace at mgora.eu. So there we have the whole platform where all the services and all the functionalities are available, where the IT experts can create their assets, the assets that they want to offer to third parties, and based on that, use different business models to describe them, let's say pay-per-use or pay-as-you-go. Then we have areas for domain experts where they can create models and behaviors, and for manufacturers, they have the possibility to either register their equipment or use equipment from third party through the platform so that they can start using what we internally call manufacturing as a service, or is also known in some contexts, equipment as a services, and also where they can describe and use the data that they own, as well as the manufacturing process that they have. And of course, it is, let's say, complete platform trying to address not only the technical aspects, but also trying to bring possibilities to provide training and consulting offerings, and giving the possibility to the peers and the experts to interact with one another. So if you want to know more about DIGITbrain, we have a couple of events today. So at 2:45 in room 4F, we have a dedicated session where we are going to go into more details of what I was referring to today, or just right now. And 1 hour later at 3:45 in room 2H, you will have the opportunity to talk with all the experts and perhaps to do some hands-ons. And finally, during the whole day, we have a booth in the exhibition, so come at any time. We will be happy to answer any question.
Very good. Thank you very much, Sebastian.